In lesson 7, they want us to prove trigonometric identities. Okay, remember trigonometric identities, you're proving that left-hand side is equals to the right-hand side. The left-hand side equals to the right-hand side. Okay, we're going to prove that now. Perfect. So on A, I'm going to take the left-hand side and prove that it is equals to the right-hand side, right? So here, let's see. Okay, this one, I'm going to write it the way it is. It's sine squared alpha. Then these two brackets here, they are multiplying each other. Do you see them? So you'll do this multiplied by that, this multiplied by that, this multiplied by that, and this multiplied by that. But to save time, I can see that this is actually the difference of two squares because I have a cos, I have a cos, I have a tan, I have a tan, and I have a plus, I have a minus. So I can just say plus cos squared alpha minus tan squared alpha. And then remember, sine squared plus cos squared is equals to 1. So it's going to be 1 minus tan squared alpha because these two, when you add them, you get 1. Then which is equals to the right-hand side. Right. And that's it about that question. Okay. So now we're going to do the second one. Okay. Which is B. Let's check B. I'm taking the left-hand side again. Left-hand side. So this part here still remains the same. It's 1 over cos theta, right? Then I have minus cos. This one is an identity. It's sine over cos is this one, you see? So which means on the numerator, I'm going to have sine, and then in the denominator, I'm going to have cos. So I'm going to write it as cos theta. Okay, remember, this is the numerator. So the numerator for the tan squared is the sine squared theta, right? And then the denominator, it's cos squared theta, right? Awesome. And then this, let's see now, 1 over cos theta, right? Minus, so let's see. Here, the cos will cancel with that, but here, because we had a square, we'll still have a cos of theta there, right? So basically, we have 1 over cos theta, and then, but we still have sine squared. So basically, this one here was not necessary. I can just say sine squared theta. And then now that I have a minus, and then my numerators are already, denominators are already the same, I can do this. I can say cos theta, it's 1 minus sine squared theta. Remember, 1 minus sine squared theta is here, is the same as cos squared theta. So I'm going to replace 1 minus sine squared theta by cos squared theta, and then divided by cos theta, which becomes, this will just give you cos theta at the top. Do we see it? Which is the right-hand side. Then that's finito for B. Let's now do C. We're gonna do C now. I'll just have to cancel this part. Delete. Need to delete this part. Delete. Sorry. Delete. Sharp. Okay. So now we can do C. Okay. So on C, right, by the look of things, the most complex side is the right-hand side. So I'll take the right-hand side in this case, because it's the one that looks more complex. Ne? So the right-hand side is equals to sine theta plus cos theta minus 1 over sine theta plus cos theta, right? So here I can see that, okay, I have what? I have a fraction and I'm minusing. Okay, this one I can convert it to one fraction, right? So I need to do the lowest common denominator, which is this one here, right? Which means this fraction, I need to multiply it by that part so that the denominator can be common. So I'm going to have sine theta plus cos theta in bracket over 1. Then I need to multiply top and bottom by sine theta plus cos theta, which is my LCD, right? Over sine theta plus cos theta. Then I'm going to have to minus 1 over sine theta plus cos theta. Right. And then now my LCD is going to be common, which is sine theta plus cos theta, right? And then here I need to FOIL these two brackets. This times that gives me sine squared theta. This times that will give me sine theta cos theta, which will also, this one will give me sine theta cos theta. So at the end here, I'm going to have 2 sine theta cos theta. Remember, guys, when I multiply this one and that one is sine theta cos theta. And then also this one and that one will be sine theta and cos theta, and all of them are positive. So I'm just saving time. We'll just add those two answers to get 2 sine theta cos theta, and then plus cos squared theta, right? And then minus 1, right? Remember, we're writing it under one fraction now. Okay, and then this becomes, remember, sine squared plus cos squared is 1. So you're going to have 1 plus 2 sine theta cos theta minus 1 over sine theta plus cos theta. This becomes 1 minus 1 will cancel. So you have 2 sine theta cos theta all over sine theta plus cos theta, which is equal to left-hand side, right? You check there, we have that exact same answer here. So we are sorted with C. Now we're going to do D. Okay. Now let me just erase first. We're going to do D now. Okay, let's go to D. So on D, let's see, D. Okay, obviously the left-hand side is the most complex side. So I'm going to work with the left-hand side. So this part, I'll just leave it like this. So which is cos B over sine B. And then here I'm having 1 tan B, remember it's basically sine B over cos of B. And then I need to multiply by cos of B. Okay, perfect. So I prefer to simplify what is inside the bracket first, and then I can now multiply after, right? Bracket first, remember, BODMAS. So my LCD, I can see that is what? Is going to be sine B times cos B. So it's going to be sine B multiplied by cos B. Right. So here to have sine B cos B, I need to multiply by cos B. So whatever I multiply by at the bottom, I must multiply by at the top. So I'm going to multiply by cos B. For here to have sine B cos B, I must multiply by sine B. So by sine B, even the top, I'm going to multiply it by sine B. Right. So here cos times cos, it's cos squared B. Sine times sine is going to be plus sine squared B. And then you have cos B over 1 basically here. Right. Perfect. And then we can all see that the top is going to be 1 for this, right? And then the cos B at the bottom must cancel with that one at the top. Then you have sine B then, which is equals to the right hand side. And that's it for that question. We're going to now look at E. Let's look at E, ladies and gents. Let's look at E. So on E, obviously, as always, we take the complex side, which I'm sure you could all see that the complex side is the left hand side. Right. So here I need an LCD. Right. And we can all see that my LCD is going to be 1 plus sine theta. And then you have 1 minus sine theta. Right. Good. That is our LCD. Ne? So now, to have an LCD here, obviously the bracket that I'm going to multiply by here will be 1 minus sine theta, right? So that I have 1 plus sine theta, 1 minus sine theta. Then this side I'm going to multiply by 1 plus sine theta. So whatever you multiply with at the bottom, you multiply with at the top. So multiplied by 1 minus sine theta. Here I'm going to multiply with 1 plus sine theta. And then it's just 1 times 1. It's 1. 1 times negative sine theta is negative sine theta. 1 times 1, it's 1. 1 multiplied by positive sine theta, it's positive sine, right? It's positive sine. So it's going to be, let's see, it's going to be sine theta there. Sine theta, sharp. And then the sine theta will cancel the sine theta. So at the top you have 2 because it's positive 1 plus 1, right? Then the bottom, if you can remember, this is this, you see? This is this part here. So it's cos squared theta, basically. Cos squared theta, right? Okay, but this does not look to be the same as that one, right? So this is what you are going to do if you get across as cases like this. You'll have to prove them separately then. Then I'm going to take my right-hand side now and prove it as well, right? So the right-hand side, I have this, okay? I have 2 there, right? Then I have sine. I have cos at the bottom. The tan is going to change to sine over cos, right? So the sine over cos, which means numerator is sine, denominator is cos. So the numerator will be sine theta, and then the denominator will be cos theta. And then this sine will cancel that sine, which gives you 2 over cos times cos, which is cos squared theta. Now you have shown that the left-hand side equals to the right-hand side. Therefore, left-hand side equals to right-hand side. And that's it for E. We're going to do the last question now, okay? On reduction. Okay. On reduction, we're going to do the last question. Yeah, let me clean this part here with the eraser. Okay, let's do F. So for F, right, we're going to take, I'm going to take this side, yeah? The left-hand side. Left-hand side. So here, I'm firstly going to change this part here. So which is 1 plus sine squared alpha over cos squared alpha. Then I have cos alpha there, right? Which becomes, here obviously I need to do LCD, which is cos alpha. I'm sure by now you can easily see that this will be cos squared alpha plus sine squared alpha all over cos squared alpha. Why? Because this, if you check this, I'll show you now. Here you're going to multiply by cos squared alpha. But what you multiply at the bottom, you must multiply at the top. So you're going to go have cos squared alpha plus sine squared alpha all over cos squared alpha. Then multiplied by cos alpha. This becomes, the top becomes 1. Then the cos squared alpha at the bottom will be multiplied by that one at the top. So at the bottom will still be having 1 more cos alpha. Because cos squared alpha, it's cos alpha times cos alpha. So one of it will cancel with that one. But this is not the same as the what? The right hand side. So we need to do the right hand side separately then. Okay. And see if we're going to get the same answer, right? So the right hand side, we have 1, let me just write it here, 1 minus tan alpha over cos alpha minus sine alpha. All right. So in this case, this is what I am going to do. Firstly, I know that here I have something like this, basically. I have 1 minus tan alpha becomes sine of alpha divided by cos of alpha, right? And I'll put a bracket. And then because this part is still a denominator, I'll just do this. I'm still keeping it a denominator, but on the side, you see? So it's going to be cos alpha minus sine alpha. Right? It's like basically writing this as this. It shouldn't confuse you. Né? At the top, you have 1 minus tan alpha. Then you multiply by 1 over what is at the bottom, which is cos alpha. But here, this must be in bracket there. Minus sine alpha. Do you see it? Awesome. So this part is this part here. Perfect. So now here I need to do LCD. This one is in bracket. I need to do LCD here, which we can all see that is going to be cos alpha minus sine alpha divided by cos alpha. Because here it's over 1, I need to multiply by cos alpha, top and bottom. So you have cos alpha minus sine alpha all over cos alpha. Then I multiply by 1 over cos alpha minus sine of alpha, right? Then we can all see, ladies and gents, that this part will cancel with that part. Then at the top, I'm left with 1. At the bottom, I'm left with cos alpha. Therefore, we can all see that this and that are now the same, which is left-hand side equals to right-hand side. So I'm sure we're learning a lesson here that some of the identities will require us to firstly prove the left-hand side And if the answer is not immediately the same as the right-hand side, you shouldn't panic. You're going to take the right-hand side and prove it and see if you don't get the same thing, right? Ladies and gents, thanks for your time and keep on working hard. Practice. You only get better with practice. Access question papers and yeah, keep on being a soldier that you are. Finally, please do me a favor and subscribe to my YouTube channel, Maths Fanatics 24/7. And don't forget to share with family and friends who will benefit from this. Thank you.